This video I'm going to discuss about searching algorithms. Searching algorithms are methods or procedures which are used to find a specific item or element within a collection of data. These algorithms are widely used in computer science and are crucial for performing tasks like searching for a particular record in a database, finding an element in a sorted list, or locating a file on a computer. There are generally two commonly used searching algorithms. One is linear search and another one is binary search. In this video, we'll discuss linear search, and in the upcoming video, the binary search concept will be discussed. So, what is linear search? It's a simplest searching algorithm, and it traverses the array sequentially to locate the required element, and it searches for an element. The linear search will search for an element by comparing it with each element of the array one by one. So we can call it as a sequential search, since it's a sequential algorithm. Why? Because we start from one end and check every element of the list until the desired element is found. Basically, this linear search is a very simple algorithm. So especially when this linear search will be used, means when the number of elements are very lesser in an array. Let's take one example. So there is an array which has n number of elements. Here the n value is 8, because in an array there are 8 elements are there. So this is the example. So the very first step is, when we implement the linear search, the very first step is we are supposed to specify the key element which we want to search. For example, the key element which I want to search is 42. So now I am going to start checking an array one by one right from the first element to identify whether the key element is found inside an array or not. So the step is comparing my first element, which is 34, with my key element. My key element is 42 and the current element which I am going to compare is 34. So compare 42 and 34, which is not equal, which means in the very first position the key element is not found. So increment now. Now the current element which I am going to compare from an array is 10 and the key element is 42. Again, the key element and the current element is not equal. Increment to the next position. In the next position, I can find the value 55. Compare 55 along with the key element. Again, it is not equal. If it's not equal, we are supposed to keep on incrementing the position and we have to check with the new value. Next is 20. The current element is, compare 20 with the key element. Again, it is not equal. Increment the position. Now my current element is 42 and my key element is also 42, which means both are equal. The element is found. So when the element is found, the algorithm will return the index position of the key value. So the index position is 4. So it would return the index value 4. Okay. So now the element is found at the index position 4. For example, the element which I want to search is the key element now. Now the key element is 5. We are going to use linear search to find whether the element 5 is found in an array or not. Again, we are supposed to start from the first element. Because it's a sequential search, we are going to compare the element one by one along with the key element. Okay, the first element in an array is 34 and the key element is 5, not equal. Again, compare with the 10, increment the position. The current element is 10, the key value is 5, which is not equal. Again it will compare with the 55, the key element is 5, again it is not equal. Then again the next current value is 20, compare with the key value, not equal. Increment again, 42 not equal to 5, then again 9, which is not equal. Again 59, which is not equal to the key element. Again 70, which is not equal with the key element. It would try to increment the position, but since we will be using the loop over there, it would be iterating for n minus 1 till n minus 1 number. There are no element found, which means the key element 5 is not found in an array. So this is how the linear searching algorithm works here. It would be searching for an element sequentially in an array. So now let's discuss about the time complexity of an algorithm. Before we discuss about the time complexity, let's discuss the pseudocode. The pseudocode follows the iterative procedure. Since it's a sequential search, we are going to start from comparing the elements right from the first position in array till the last position until the element is found. So we will be using the loop. The loop starts from 0. If the loop starts from 0, we will be iterating it till n minus 1. If the loop starts from 1, we would be iterating till n. So we are going to compare the element in an array along with the key element. If the element is found, if the array element and the key element is equal, it would return the location of an element, the index position of an element. And if it will come out of the if, and it would come out of the for loop. If the element is not found, set location equal to -1 int. This is the pseudocode. So there will be loop because we want to compare the element one by one. So now the element which we want to search is equal to the current element in an array. It would return the index position of the element if the element is found. Otherwise the element is not found. Until the last element, it would keep on incrementing and it would be checking. So till the last element, if it is not able to find the key element, means it would return -1, which means it would print the element is not found. When it comes to time complexity, this time complexity can be computed by analyzing an algorithm, by analyzing an pseudocode. So this is the pseudocode given. If we check when there are n number of elements, the loop would iterate for n plus 1 number of times, and inside the loop these are the statements, and how maximum in the worst case scenario how many number of iterations it would take means the inside statement of for. This would take n number of comparisons would be made, and it would print the location. If it is equal, it would print the location. So this is for n number of times, and loop for n plus 1 number of times. So when we add it, n plus 1 plus n to n plus 1, which means after ignoring the constant, we would be getting the complexity n. So we have applied the operation count concept to trace the algorithm and identify the pseudocode. So there are 3 cases under the time complexity. One is worst case, then best case, and average case. Worst case is nothing but the maximum time taken by an algorithm. Best case is the minimum time taken by an algorithm, and average case is average time taken by the algorithm. So mainly we go with the worst case. We go with calculating the worst case for all the problems. So the worst case scenario is when the element is found at the very first. Worst case is the maximum time taken by an algorithm. So when it would take maximum time, the maximum number of iterations it would take means if the element is found at the last position. For example, the key element is the key element is 70. If the key element is 70, since it's a sequential search, we are going to start from the very first element. By comparing each and every element with the key element, we'll be able to identify the position of the element which we want to search. For example, the element is 70, I would be iterating till the end, which means if there are n number of elements, I'm supposed to traverse for n number of comparisons, n number of iterations. I would be making n number of comparisons. So this is the worst case. If the element is found in the last position in an array, it is going to take n number of iterations, and also if the element is not found also, till here my algorithm would traverse. So the worst case is big O of n. What about the best case? For example, the key element which I want to search is 34, which means the element which I want to search is found at the very first position in an array. So the number of iterations it's going to take us only 1. The number of comparisons it is going to take us only 1. So the best case complexity is going to be only 1. So the best case is only one, which is the minimum time taken by an algorithm. When my algorithm would take the minimum number of iteration means when the element is found at the very first position, and average case is somewhere in the middle. So again the average case is going to be theta of n. So these are the time complexity of the linear search. So the linear search travels through every element sequentially. Therefore the best case is when the element is found in the very first iteration. So the best case complexity is omega of 1. And the worst case, as I discussed already, it would be an unsuccessful search. Otherwise the element which is found, if the element is found at the very last position, so the complexity is big O of n. Thank you.